Hello friends, welcome to the Tech Granth. Today we are going to talk about a probabilistic data structure and it is called Bloom filter. So before we jump into the details of the Bloom filter and how do we create it and how do we use it, let's first look at the case where why do we even need a Bloom filter. So the first requirement is that we want to check if a username is available or not. So this requirement is, for example, if you go to Gmail or Yahoo or any other website and you want to create a user ID for yourself, so there is a check in the background which will tell that whether that username is already taken by someone else or not. So this is a scenario where you should not get a false positive answer that okay, it is not available, but you got the answer that the username is available, because it will cause a clash. So this is a classic example for Bloom filter. Next is if you want to check if some string is not present in a very big list. So you have like a stream or a very big list or a file and you want to check whether something is not present in that list. So this is a negation. This is the point to be noted, that the important point here is that that string is not present in that list. Next is optimize database call, so that in case when you return a null set, for example, you have written a query and the output of that query will is going to return a null. So the query is very big, it is going to scan a lot of rows and then filter out columns and then do a lot of processing, and finally if the operation results in a null set, then you are basically wasting your time and resource for that particular query. So to optimize that call, that if the output is going to be a null set, uh, we use Bloom filter. Not we, actually the optimizer, the query optimizer, it uses Bloom filter, and we'll discuss about this in detail in the coming video. Because you might have seen in your if you have worked with database, like if you have written queries in Oracle or Cassandra, and suppose the query is very big, the processing takes a lot of time, but in scenarios where that query is supposed to return a null set, the query executes very fast. So you should thank Bloom filter for that. We'll discuss about this. Next is that the all the above operation where we want to get if the set is null or if something is not present, we want to perform all these operation in constant time and space. So suppose we have a very big list, and if we want to find a string which is not present in that list, it should not be like I go for a linear search and I check one by one for each of the element and see okay, it's not present. So if the list is very big, if suppose it's a big file, then it will take a very long time. So these are the scenario where Bloom filter can come very handy. So let's take an example to understand it better. So you have been given a list of place, like you have Delhi, Mumbai, Kolkata, Chennai, Bangalore, Hyderabad, and we need to find if Varanasi is present in this list or not. So what are our options to find the whether Varanasi is present in this list or not? So a simple solution will be the brute force one, which is the linear search. So you go to this list, check for each item one by one, check whether this is Varanasi, this is Varanasi, this is Varanasi, and go on and on. So what happens here is that you go through the list one by one and see if the element is in the list is Varanasi or not. So this takes a time complexity of order of n, and it will be very slow if the list goes on and on and on. And if suppose this list is present in a very big file, for example, so this will be a disaster. Now the second option that we have is we go for binary search. Now for binary search, it's okay if the list is already in a sorted order. So if you got this list and the list is already in a sorted order, then you can go for binary search and it will take a time complexity of log of n. But if the list is not sorted, which can be the case in most of the scenario, so you need to sort the list first and then only you can apply your binary search. So this will take a time complexity of n log n, which will again be slow for very big file. And the third option that we have is, of course, the Bloom filter, which we are talking about in this particular video. So what Bloom filter, it will do this operation in constant time and space. So now let's learn about Bloom filter. So what is a Bloom filter? How it is used? So Bloom filter is a probabilistic data structure. So if you have followed my channel, you might have seen that I talked about another probabilistic data structure which was count min sketch. If you have not checked that out, The link is there in the description and also in the I button. You can check that out. So that was for counting, uh, basically count means sketches for counting if some element is repeated how many times of minimum number of times. So you can check that out. That is another probabilistic data structure. Next is that the Bloom filter is used to test if an element is a member of set or not. So here Bloom filter basically talks about the negation part. It talks about if an element is certainly not present in a list, then it will say that it can say with 100% guarantee that it is not present in the set. For positive case, we'll see whether it can tell whether it is present or not with 100% confidence or not. Next point is about Bloom filter is that it performs operation like not in and not exist. So if you're writing a query and you have put name not present in a list, or whether it name does not exist in another table, if you're joining two table kind of thing. So it perform all these operation in constant time and constant space. Next is it never gives false negative. So if Bloom filter output says that it is not present in the list, it means that it is not present in the list. That is for sure. That it can give false positive in case of hash collision. So now this is why this particular Bloom filter or this particular application is a probabilistic data structure, because something it depends on probability and it can give a false positive output. So why it can give false positive output is because in case you are using some hash function, here we will discuss about all these things in detail in coming slides, but for now just understand that if you are using some hash function and there is a hash collision, so in that particular scenario your Bloom filter can give a negative false positive. So it can say that yes, it is present in the list, but in actuality it might not be present in the list. But it will never happen that Bloom filter says that it is not present in the list and it turns out that that element is present in the list. So it never gives false negative, but it can give false positive, and we'll see how. And finally, once a Bloom filter is created, we cannot remove an item from the Bloom filter. So now let's look at how Bloom filter works. So for Bloom filter, we need a bit array. So suppose this is the bit array of 20 bit. So that is how we have fixed the space. So space is fixed for Bloom filter. Now we'll see how time complexity is fixed. So we have multiple hash functions. So for this particular example, we are considering we have three hash function 1, hash function 2, hash function 3. So suppose the list that we are processing, it has first element as Delhi. So we passed Delhi through hash function 1 and the output we got was 5. Now since this is a hash function, it works in a constant time. So since it works in a constant time, so for Bloom filter we see time complexity, space complexity, both are constant. So for Delhi the output is 5. So what we'll do is we'll go to fifth bit here and we'll set this bit. So we'll set it to 1. Next we'll pass the same element Delhi to hash function 2. So hash function 2 gave output as 8. So we'll go to 8 and we'll set the output as 1. And finally we'll go past this element Delhi to hash function 3 and it said that it's 15. So we'll go to 15 and we'll set this as 1. So for Delhi our table is ready, or the hash function is ready for a list which contains only Delhi. So it will have 5, 8 and 15 bits as set, rest all as unset. Now let's take another example. So for Kolkata, when we passed it through hash function 1 we got 3, so we set 3. When we passed it as hash function 2 we got 9, so we set 9, and for hash function 3 we got 13, so we have set the bit as 13. So now for the list that we have, the bit array that we have, this is the Bloom filter for us. Now let's see the third example where we have Mumbai. So for hash function 1 we have 14, so we set 14 as 1. We have 5 we have already set for Delhi, so it's already set as 1, so we'll keep it as 1. And finally for hash function 3 we have 9. Now 9 was also already set because hash function 2 for Kolkata returned 9, so this will also be set as 1. Okay, so till here we have a list which contains Delhi, Kolkata and Mumbai, and this is the Bloom filter, or this is the bit array which represent that Delhi, Kolkata and Mumbai are present in our list. Now if we want to search for something, so let's say take the example which we have the negative case. We said that we want to search whether Varanasi is present in this list or not. So for Varanasi, we passed Varanasi through hash function 1, 2 and 3 and we got the output as 0, 14 and 19. So we go to 0 and we see that it is not set. We go to 14, we see that it is set, and we go to 19 and we saw that it is not set. So what we are going to do is we are going to AND all these solutions. So we have for 0, we have 0. We'll, it means it's false. It is not present. We'll do false, and for 14 it is present. So we'll say, uh, let me write it down. So for this one, what we are going to do is, so this is false, this is true, and this is again false. So when we do AND for all these scenarios, the output will be false, which means that Varanasi is not present in our list. So let me just clear it off, and we have the laser pointer back. So what this means is that Varanasi is not present in the list, which is the negative case, and it tells us perfectly that Varanasi is not present in this particular list. Now let's take a positive case. So if I want to search whether Delhi is present in this list or not. So for Delhi again we'll pass it through hash function 1, 2 and 3 and we got the same result like 5, 8 and 15. So we got 5, 8 and 15 and we checked 5 is present, 8 is present and 15 is present. So when we AND all the scenario, all are true. So it means that Delhi is present in the list. Now let's take a third example, and this will clarify why we say that Bloom filter, it always tells us that it never gives false negative, but it can give false positive. So let's take an example and we say we have to find Chennai. Now we pass Chennai through hash function h1, h2, h3 and we got the value as 8, 13 and 14. So we go and check for 8. Okay, the bit was set. So this is true. We go to 13. Again, this was set. So we say true. We go to 14 and we say that this bit was set. So this is also true. Now when we AND all these three, we say that okay, the output will be true, which means that Chennai is present in our list. But till now we never processed Chennai. When we created this list, we only created Delhi, Kolkata and Mumbai. We never added Chennai to our list. So how come it's saying that Chennai is present in our list? It's because all these bits are set. Now how 8 was set? 8 was set because for 8 it came from the hash function 2 of Delhi. So there was a hash collision between h2 and h1's value, and both returned the same value when an element was passed to this function. When we go to 13, so this was also set. Now how this was set? This was set from here. This was set from h3 of Kolkata. So again there was a collision where h2, whatever value h2 returned, the same was returned by h3. And when we check 14, so 14 how we got was, so 14 was returned from the first hash function of Mumbai. So here we see that okay, h1, h2 and h3 all have collided the value with one of the function for other element. So as a result of which we are getting a false positive. So that is why Bloom filter we cannot trust when we are looking for a value whether it is present or whether it is present in the list. If we want to check whether something is present in the list, we cannot trust Bloom filter. But if we want to check if something is not present in the list, we can trust the Bloom filter and it will say with a guarantee that the element is not present in a particular list. So this is how Bloom filter works. Now let's take another example, or let's talk more about Bloom filter and how it is utilized basically in a real world scenario. So we have this bit, suppose this is a bit array where we have 0 bit as set, 3 as set, 5 as set, 8, 9, 13, 14 and 19. These bits are set. So the Bloom filter in binary format, it will look something like this, and the corresponding decimal will be a value like this. Now when this above decimal number, so whatever decimal number that has been converted here, this is called the Bloom filter. This is the point to understand. And now how we will use it. So if suppose we have a function where we want to find whether something is present in the list or not, so there what all things we require all the hash function that was used to create this bit array. In the previous example we saw that there were three hash function that was used to create this bit array. So if we want to decode it also, we need all those three hash function, and we also need the Bloom filter. And Bloom filter is nothing but this decimal representation of the bit array. So if there is a function which tells us whether an element is present in the array or in the list or not, so it requires all the hash function that we used, and it requires this number, which is the Bloom filter. Now using this, what that function can do is it can compute the using the hash function, it can compute the value, and using this Bloom filter it can check whether those values are present or not present. So if it is not present, it will straight away say that that element is not present in the list. Now let's see the use case of Bloom filter. So first use case is in database like Oracle Cassandra, where Bloom filter used for lookup of query. So this is what I was telling you before. So what it does is it optimizes the result set, it optimizes the IO, and if you see the query plan, uh, where you have a very big query which expects to span over a lot of data sets, so you will see a step there in the query plan which will say that there is a step for Bloom filter creation, and there is a step to implement that Bloom filter or use of that Bloom filter. And this will all this these two things will always come in case where we have basically an operation like not exist, not in. So there what Bloom filter does is it will basically look into the query, and it will create the Bloom filter for that query condition, and it will in the use it phase it will pass that Bloom filter and the hash function. And if suppose the first operation it will do is it will check whether it is not present or whether it is present. So if it is not present, straight away from Bloom filter only it will return the result. It will not even go and check into the table whether those values are present or not present. So that's how this operation will take place in memory, and the operation will be really fast. So that is why when you fire a select statement which is very complex, and if you are supposed to get a null set, you will get the result very fast because it is returned just from memory. Whereas if it is supposed to return some result, it might take some time because it will go and it will check into the data file whether those records are present or not, in case it is not present in memory. So that is why the false returns are very fast as compared to true return. So this is a very typical use case for Bloom filter. Next is it is used as efficient data structure to see whether a username is available or not. So again, this Bloom filter will be shared in memory, or it will be shared across the application server for any email kind of thing or an application where you need to check for a username. Next is some browser, or not some browser, in most of the cases the browser uses Bloom filter to identify malicious URL. What happens is in your browser, uh, as part of your browser setup, it will store the Bloom filter, and it will also store the hash function that was used to identify a malicious URL. So what the browser will do is it before redirecting to the actual URL, it will check the Bloom filter whether this is listed as a malicious URL or not. If it is not present, then we for sure know that it is not a malicious URL, and you will be redirected to that particular URL. So that is another important use case, and very good case for Bloom filter. So finally, for the recommendation system also, so if you are going to a blog like medium.com or blogspot.com, so suppose if something was already recommended to you, so that can be set as part of the Bloom filter. And if the blog was recommended to the user before or not, so you can basically, not you, the recommendation engine can check using that Bloom filter whether this was already recommended to the user or not. If it was already recommended, maybe it is not required to be recommended this time. So wherever you have a scenario like recommended or not recommended, and your output or your next operation or next step will be based on the negation output, which means that whether it is not present, then I need to do something very fast. So that is where bloom filter comes into picture. So this is the use case and how you create a bloom filter. So that is it for this particular video. Hope it was informative. Do hit the like button if you have reached here. Subscribe to the channel to get the update. Thank you.